so I'll excuse you, forgive you if you fall asleep during this presentation, but I'll try my best to be entertained. For those of you who don't know me, I'm Alan Rose, and I'm going to talk about flying through the clouds, or how to microservice. Basically, this is similar vein to Don. I'm going to just give a bit of a slice of my experience in developing in the cloud, explain my some problems I had with it, something I wanted to do, solve, and how I went about doing it, and then what I learned from it. And hopefully I'll teach something to go here, and we have a good discussion about it. So first, this is my first time talking, I'll give a bit of background on myself. Spent about 10 years developing in a very much non-cloud environment. So, very embedded, lots of packets flying around, Wireshark, TCP, GDB. It's a good day if I didn't have to deal with kernel panic or PCI errors. So moving to the cloud, it was quite the experience. It was just the concept of a microservice. My previous job, you wanted to add some functionality to the system. It wasn't a question of how to put it into its own service. It was a question of what services it fit into best. You extended services. You never built a new one. So it's been a lot of learning, and it's been refreshing, to say the least. So, as Don alluded to, there's some contention about what a microservice is. I'm not saying that this is the answer, but I'm going to describe some things I think that are microservice, that make a microservice, and I'm going to focus on them through this discussion. Feel free to disagree with me if you do. So, microservice. Not into this again. I think a microservice is really something that is embodying a single responsibility principle. It's doing one thing, and it's doing it really well. You don't want to start tacking new functionality onto it simply because it's in a convenient location. You design a service with a goal, a task in mind, and you implement it and you deploy it. And any changes to that should be minor functional changes, maybe API upgrades, things like that. You shouldn't tack on entirely new functionality. Now, again, to something Don said, you can go the other way. You can break the microservice apart into many other small end services, and you lose cohesion, and I don't think that's good either. So you really want your microservice to be one thing done well.
Goldilocks.
Yes. Perfect size. Property microservice you tend to find is, well, because you're breaking your functionality up between services, they aren't in the same memory space anymore. To actually do anything, they need to talk to each other. So you have networking. Networking enters the picture. There's a lot of packets flying around the system, with TCP, UDP, IP, and the sort of trend I've seen at least is almost everything is over HTTP. So you have some sort of HTTP protocol, maybe over TLS, maybe not, but it's HTTP. And discovery at some level happens through DNS. You have host name, you look it up, you get an IP, you go. How that DNS name is resolved, that's another question. And that's, again, like the microservices Don was talking about, or sorry, the service mesh Don was mentioning. But that's how that works. A property you tend to want from a microservice is elasticity. You want to be able to scale each service individually so that as one system, part of the system becomes a bottleneck, you can alleviate that bottleneck by adding more resources to it. So you have elastic demand, more requests coming in, you have elastic scale. You scale up, requests go down, scale goes down. It's great, it's perfect. Why would we do this all the time? To make this work, you often need these things to be stateless. So your microservice is probably not running a crazy state machine internally. It's probably not accruing a bunch of information on disk and then bringing it back in from disk and then putting it back to disk. It's operating on the information it has available from the requests themselves and maybe with some backend data stores. And then they tend to communicate through fairly well-defined decoupled APIs, which gives them some nice properties. Anyway, so that's what I think microservice is. So I'm now going to discuss something I tried to do. And I think I succeeded relatively well at it. Not to cut myself back too much. But, Don has this great sock shop for cats. We notice that every once in a while, some jerk comes in and starts trolling for PHP on this and whiz-bang that, and they're clearly looking for vulnerabilities. So this technique that I first found out about when someone kept trying to hack into my computer at home, like my Switch server. I noticed a bunch of failures in the logs, like thousands of them. I'm like, whoa, that's not good. So I found out about Curelet-Balan. It's something that you can run on your server, and it scrapes this log, and it says, oh, this IP is trying to log in to any time but failed. Put it in like the deny list. It is never allowed to log in again until you bin it the list. So why don't we do that for these accesses that are really just some sort of phishing? Right? It's phishing for a vulnerability. Let's prevent that from happening. When we see too many of them, let's block them. It seems easy. Except, in this nice, wonderful microservices architecture, you can't just put this logic on one server, because you might have thousands of those servers. So, you know, the 1,000 attempts that the person or that the attacker makes on your system, it could be spread out across all 1,000 of those servers, so any individual server only sees one. You're not going to block on 1.404. That's crazy. You'll block everyone. So you need some way.
It's safe.
It's true. You'll also go bankrupt. So you need some way of correlating all this information together. And that basically meant, well, I need something that's external to the service I'm trying to protect to actually make the decision and act on it. And so I'm like, okay, microservice. Seems great. I'll do that. Obvious. So how did I build it? There's a few other things involved here, and I'll walk you through them. So I have this thing called the agent. It's kind of like what Ian and I were talking about earlier. It's making decisions on packets. It's quite straightforward. It's actually on packets. It's on flows, but anyway. Packets coming from the internet, where they come in between the microservices, and the agent says yes or no. You're allowed to talk to your destination or you're not. On its own, it's going to allow it to come through. It has no rules. It has this controller, which is its own microservice, that's controlling these agents. It's saying this IP, block, this IP, allow, maybe this IP and this port, block, allow, whatever. It's just fairly standard firewall type logic. Now, you know, to actually make the controller do what I want, I have to have some way of getting a list of the IPs that are attacking the system. Well, I have a service for that. Why not? Microservice. Find the bad IPs. So, every once in a while, the controller asks this bad IP service, who are the bad IPs, finds out, tells the agents, block these IPs, done. Easy. Still doesn't answer the question of how the bad IP service gets the list of bad IPs. Well, we have this thing that I think Don again was alluding to, called FluentBit. And what it's doing is it's scraping all these logs from all the microservices in all their myriad forms, and it's normalizing them, and inserting each log into the Elastic database. The bad IP list runs a query on Elastic. It very quickly gives me a result back that says these 3 IPs have been jerks. You should block them. The controller blocks them. Pretty easy. So that's how it works. Some random IP, probably running a botnet, attacks scans, maybe 300 IPs. About 20 IPs in, the controller wakes up, asks the IP service to give it the list, and it does, and it's like, hey, this guy's bad. And the next few hundred or so attempts are blocked. The attacker gets no feedback, and the attack fails. Even if the attacker had managed to get through, its further attempts would probably also have been stymied, because it's unlikely that it would have only ever maintained one connection into our system. So it's pretty powerful. Now, you're going to ask, okay, well, what about this is actually a microservice? Well, the single responsibility principle. The agent, all it does is admit or deny packets. It's not doing anything else. It's not collecting information with packets. It's not scanning for problems in the system. It's just, is this packet good, yes or no? The controller, its sole responsibility is for updating the agent. That's all it does. It doesn't talk to anyone else for any other reason except to get information that it needs to update the agent. And the bad IP list's sole job is to calculate the list of bad IPs by running queries when asked. It's stateless because the agent just has a cache of rules. It's not writing into disk. It's not building different packets or any state as it gets packets in the system. It says yes or no. I'm given my rule set, given my packet, here's the answer. The same rule set, the same packet would always get the same answer. It's identical. Likewise, a controller builds rules from a rule database and the result of the query. The same rule database, same result, same answer. There's no intermediate state that it uses to make its decisions. And the bad IP list is extremely simple because it just basically forwards a query. When it gets a request, it queries the database and sends a request, the response back to the controller. And there's nothing to keep. The APIs are fairly decoupled. So the API shows between a bad IP list was actually inspired by some online blacklists, which are literally just lists of IPs that are new line separated. So I'm like, well, okay, I'll just query that API and I'll get a new line separated list of IPs. And if I ever wanted to use a different service for that, like maybe point it at a blacklist on the internet, I could do that. It's great. It's super. So I made it sound all wonderful and happy, but it wasn't quite so easy. I mean, I didn't get this all done in a week. So what happened? Well, I jammed my own IP.
More than once.
Yes. It turns out that it's really easy to get 404s on your infrastructure, particularly when Chrome is just like, let's look for some random like favicon and other thing that don't exist. And then the infrastructure IPs, well, they were trying to find out stuff's coming up, they're probably going to make sure it's good. Well, let's get 404s. Oh, too bad, you're banned. Now everything's down. So you got to be a little careful with stuff like this. Even when I wasn't banning stuff, the infrastructure was dropping connections. I don't know what's wrong with Azure, but it seems to have problems in its networks. Because you have, I was using Kubernetes, and I'm talking to the Kubernetes API to get some information. I'm watching for changes in statements in a few places. And they would just barf. I didn't have this problem when I was watching my VM on my laptop. Why the heck am I having this problem in Azure? Well, it's the cloud, stuff moves around. Logs went missing. I relied on these logs. I mean, this isn't exactly the most bulletproof way of doing things, but it was the simplest at the time. I relied on these logs to tell me what happened. And when the logs go missing, I don't know what happened. And it wasn't that they just didn't go, it wasn't just like a few logs went missing, it's like entire services would just disappear, and you wouldn't get any logs from them. Or the logs would parse correctly. I would expect them to appear in a certain format, so like query would work. Yeah, no, you just get, a text blob. It's not elastic, it's nice at all. Other fun stuff, races on install. You go to spin up your container. Well, it has to, maybe you want to set some stuff up in it first. Not going to be stateless, but you still need to do some bootstrapping. If you're not careful, that bootstrapping might have to, I'll give you an example. I needed to put some information into Elastic. When we first installed the Elastic system, I wanted to create some aliases, some templates, some things like that. And the service that was actually doing that wasn't Elastic itself. So I'd spin up Elastic, I'd spin up the service, and the service I would assume that Elastic was up and running, but really Elastic might not be yet. It says it's up, but it's not actually up. It's not ready to respond to queries. So a query would come in, or I would send a request to it asking to put the information in the database, and it just failed. So if I didn't look at the logs, I wouldn't have seen anything. Not so great. Read-only containers can cause problems. So good practice is to make your containers file systems read-only. It should be fine since they're stateless. It shouldn't be.
I'm just going to stop on this. So I thought that everybody made their containers root file system read-only. And there's some guy responding to my blog says, well, I went through every chart in the Helm stable repo. There's like 4 out of 234 to do. Anyone? Crickets? Crickets? It's an easy thing to do.
That's probably why they cause problems, because no one does it.
And if they do it, then you can shoot it in the head because it hasn't written anything in there.
So the problem I ran into, it was more Don ran into it, was a message bus we were using was briefly storing some information for persistence reasons, which we didn't care about on disk. And if that store didn't work, the query it would just randomly fail. It itself broke. So there was no logging, nothing. It just sometimes your request would fail. You had no idea why. It really sucked. I mean, I'm sure Don can grumble that more, but
it was the message broker that Ian was saying was such a good idea.
Is there one
It was Ian.
I had some real angst and pain with container labels. So I don't know how many of you use containers. Probably a lot. But if you're using Docker, you label containers. Right? There's a giant crazy hash that describes a container. You don't want to use that.
And you do that because you don't want to pay for having more than one container. So you concoct crazy labels for other containers.
Well,
No, he's talking about the hash. What you're talking about sounds different.
Yes. So you have your repository, and you like it's like food : bar, right? And the default one is the latest. If you don't put anything, it just grabs the latest. It's even great. It's like, oh, I always want the latest one. Why don't I always use that?
Why wouldn't I?
Well, you think you've done, you've solved the bug. You've conclusively solved it. You wrote a unit test to prove the bug was there. You fixed it. The unit test is passing. You pushed your Git continuous integration builds your container. Great, and you go and you redeploy, and the bug's still there. What the fuck? You start debugging, and you go crazy, and you realize it just didn't pull a new container because it's the latest, and then you hate your life. And you have one of two options. I mean, you can either set the install policy on your Kubernetes to always, or you can just create a new label every time you do something meaningful.
There's also my mysterious kube control patch command.
It doesn't always pull.
And run it again.
Well, yeah. The other thing is you don't know what version you're getting on a given node as well, which is a bit of a.
You get the latest.
So that one was. I've been bit by that multiple times. I just stopped doing it. Anyway, and then, I mean, because I'm embracing open source, embracing the cloud, I'm using lots of libraries that come from open source, and they're buggy. I hate to say it, but they're buggy. I was using the Python client library for Kubernetes to do some stuff. And, maybe it's just the one API I'm using, but it has a lot of problems. It just, you're watching for a list of changes to a resource. I have this pod here's this IP now, here's this IP then, here's this IP now. And it gives you sort of like a history for the last window of time. And it gives you two in a order. That's great. And then it finishes and it's like, okay, I'm going to wake up when the next thing comes in, but I'm never going to wake up again because I actually have the wrong thing to wait for. Or then eventually, or it barfs at you because it has the wrong thing, but it never gives you the right ID to update to, so it's just stuck in a loop of failing. I submitted an issue to the repo a while ago on GitHub, and cricket's there.
So here's my suggestion on this. What works best is to submit a pull request.
Yeah.
What works second best is just to complain about it and do nothing. What works third best is to open an issue.
I have this. I mean, I figured out workarounds. The magic of Python is that it's really easy to
because now you got to defend your grumbling to other people, and they're still not going to fix it.
I think the more annoying thing is that you probably chose the wrong Python Kubernetes line. You picked number 6 instead of number 17, and that's the problem.
17.1.
No,
So that's what we found. We do a lot with Kafka, and there's like 7 or 8 different Python libraries. What one should we use?
Well, this is the official one.
So, yeah, the official one's always the worst.
It's lightly documented.
Yeah.
That's the best way to say it.
You want Python dash Kubernetes, not PyKubernetes.
Exactly.
All right, so what do I learn from this? Well, read the manual. I'm using a lot of APIs that I've never used before because I'm trying to do a lot of things really quickly because I'm trying to be agile, right? I'm trying to move fast. And it means I need to learn a lot, and you can't just, there's no one to lean on, to learn from. So read the manual, and understand that the manual might not be complete. Read it, play with it, try it first, and be careful of the warnings. Look for the warnings, because there's often, someone else is running into the same problem as you, and they actually they've been nice and they documented it. So, look for that. And not only that, if you do run into something that's not documented, feel free to like most of these things are open source. They're willing to take, if you're willing to take documentation pull requests, do that. Update the documentation, mention the problem you had, how you fixed it, and people will be happy in the future. Contribute back. Simple is good. There's a couple of cases where, I had to choose between strategies or tools, and one seemed like it was the bulletproof, future-proof way to do things, but it was really complicated. I was worried I wouldn't get it done at all. And the other one was really simple and just worked. And I ended up going with simple, and I was happy for it. You need to be careful with that. I guess I'm kind of straying into sort of just general software techniques here, but it applies at the cloud just as much as it did in a monolithic system. I feel like microservices are really just applying good software principles at a higher level. But
With smaller teams and more agile.
yes. Understand the platform we're working on. I know this is kind of, you're violating some layering principles here by having to understand what you're running on. I'm running on Azure versus Google Cloud. Knowing that there's a difference between the two is important because they do fail differently. When we went from Google Cloud for some stuff over my Minikube cluster at home to Azure, stuff failed differently. Things that I was having problems with there didn't have any problem, or on Google didn't have any problems with on Azure. Things I was having problems with on Azure didn't have on Google. It's good to know because in trying in multiple places, you find assumptions that you made that you probably shouldn't have. Or alternatively, think with things like the IP. Azure has, Don and I were looking at some logs yesterday, and we see this enormous block of traffic coming from one IP hitting our front end, and we have no idea what it is. It's Azure's, like after about like an hour of scraping through logs and trying to figure out what's going on, we realize it's just Azure doing, it's health checking. It's trying to figure out if the services are up so it can start load balancing to us. It's not obvious anywhere. There's nowhere does it say, like, in any of the Kubernetes commands you run, it's not going to tell you what that IP is. It's there.
Nowhere does it say I'm going to give you 20,000 connections a second to check if you're up.
Yeah.
On your 11 things. And then disappear just as soon as you threaten with wireless.
It's worse than that, because if we block that IP is actually the upstream DNS server also, because for the clusters. So everything would have broke. Nothing would have been able to talk out. All the other Azure stuff probably would have broke. It would have just been a disaster. So you need to be careful of things like that. If you start poking around with the layers, understand the platform. Otherwise, you're going to hurt. I'm not sure why there's an apostrophe there after before the S. I think it's supposed to be after, but I'm sure there's something funny to do before that. So strange things happen. Strange things happen, like an exclamation mark appearing in the wrong spot. Help future you out, log the strange things. Log the good things. By logging the good things, you can tell them strange things. You know what the strange thing's strange. And not only that, you can sort of squish it between the good things to figure out when it happened, helps with correlation. There's a lot of times in the last few months where something just wasn't working. I had no idea why, or it broke in the middle of the night, I didn't know why. And it wasn't in something I had written, but it was something I'd written had made a bad request, for example, to another service. And that service logged it and said, hey, here's why this is bad. That helped me solve the problem. Or I made a mistake, or another service broke, and my service logged it and said, hey, here's what's wrong. Great, I can solve the problem. Logs are a great way to figure out what happened in your really crazy, many moving parts infrastructure without having to actually be there when the event happens. It's great to actually attack the GDB and break and find, see the state exactly when it happens, but when you have 100 instances of a service, it's really hard to figure out which one to attach to, let alone get there at the right time. So logging infrastructure is really important. And it's important, and you also want to have it stored somewhere, because these services are coming and going. So something like Elastic is pretty useful. Retry. So strange things happen. Deal with them. Don't just crash and burn. Crash and burn's okay if you're covered. But don't crash and burn and just hang there for a bit. I had a service that I'd written where when a thread exited, the service didn't exit, but the thread just stopped doing what it was supposed to do. That was great. It's like, well, why am I not doing this thing anymore? Oh. Okay, well at least I have a log that tells me there's a stack trace. Good. Okay, something broke there. I can fix that.
You needed a health check for it.
Don't forget to randomize when you retry.
Yes. And no thundering herds.
Don't retry indefinitely. You will kill servers.
Yes, or that's why, or have backup as well. Don't assume because it didn't work the first time, it will work the second time. You have to think about it, right? Is it reasonable for the service you're talking to not be updated when you start? Take that into account. Is it reasonable for the service you're talking to have been restarted because it's being upgraded? Take that into account. If it's something like, hey, this is a bad query, or your thing is wrong, you probably don't want to retry there. So I guess it could be a versioning issue, so you can think about that too. The point is retry a bit. So that the case where I was talking about earlier, where the was with pushing templates to Elastic. The answer there was to just look at the error. Oh, the error means it's not quite ready yet. Try again. Wait a minute, try again. Don't go nuts and play loop and hammer it. But wait some small amount of time, randomize it so you don't have 50 things at once all hammering it, and go.
One of the things we found too is if you're not ready, respond when you're not ready. Don't just wait until you're ready. Because you end up getting all these things backed up when they could have just tried another one of your instances.
You put the power of making that decision into the caller.
Yeah, exactly.
Makes sense.
If you have a service mesh, you probably won't want to do that because the service mesh will not have you in the pool until you're help. There's two types of help checks. There's an initial help check and a runtime check.
Mm-hmm.
So as long as you fail the initial check, it'll let you keep going up, but it won't send you stuff.
Yeah, we had a bunch of problems where in testing, everybody, they go on to kind of the live system and they start the thing up and then do the testing and it's fine. But in the real world, when everything starts up at random orders, and then everybody just gets stuck thinking that nothing's really going and no one's responding.
So that's back to the chaos.
Probably a service mesh.
That's back to the chaos monkey that Lee mentioned, but Kubernetes will teach you that things always start in a random order. So eventually you will have all the possible orders solved. The easy way or the hard way.
Eventually.
One way or the other, you'll have them solved.
Just deploy it enough.
Yes.
It's probably actually, I didn't put that here, but there's an elegance or a power to the ability to just shoot something in the head. Don't quote me on that.
Hay versus houseplant, man.
Hay versus houseplant. Pitch in the hay? Did I get that? Is that the right term?
You shot my philodendron.
You're not far off with that comment, actually, because, particularly when you start using Kubernetes, you start realizing there's really not a way to restart this container
Nope.
manually.
No.
You just delete it and let it create a new one, and it behaves the same.
Or it's like-
unless you restart, you delete it.
It's like, I want to try new config, just kill it.
Or you could use my kube control patch command, which Kyle doesn't think is good. But
I think that's one of the powerful things about containers and microservices, though, is all the stuff you would used to have to build Control-C and up to reload config, and it's just all.
Well, it's kind of forcing you
Ah.
to think. It's kind of
yeah.
if you drank the Kool-Aid, you're doing it the right way, and you're making it stateless, and that means you can just kill it. There's no downside to doing that. It'll come back up. You let your controller, your orchestrator, bring it back up, and you're good to go. And it's just, it's misbehaving. I figured out what's wrong. It's okay, it's killed. Comes back. We're good. It's just, I don't know. You're running control delete tens, if not hundreds of times a day, probably when I'm doing development. Just want to try something else, you kill it. It's just makes you feel warm inside. It's very different from having physical hardware, sure. Which hand wired lovingly. Okay, and notice everything will be there. So design for services to come and go. If you can, do some sort of fallback, that might not be an option. This is similar to the retry loop, but you need to think about what happens when a request fails. You pass it up, you put it on a loop to retry later, something like that. But make sure you think about that because it will, because you're killing things. I mean, I'm advocating for killing your pods left, right, and center, or your containers, but while they themselves may not have any state that matters, other things might have things in flight that they're responding to, and they may be unhappy. So you don't want to have this chain killing everything for things to keep working. You want them to come back and.
Plus, a lot of things use a lot of CPU to start.
Yes, that's
Like Java's bad that way. It's real expensive.
So you want to only kill the things you need to kill, or over water.
Don't be a serial
whatever.
killer.
All right, that's it. Any other questions, Brad?
Probably more of a comment than a question, but the architecture you have laid out, it's following all the principles, but for, let's say you're a small startup and you're starting out, your requirements are super low, you would never split that design into 3 different services, would you? Or what's the cost of splitting it up into all these 3 different services? Is it possible to do?
I think that's the nano service concern that I had earlier.
So these services are, We are a startup. It didn't cost me much, honestly. Once I'd done the first one, it was actually quite a bit easier. Now I'm not doing things as well as I should be. I'm not defining. I was talking to Pito about this earlier today, and I'm like, I need to start using Swagger and define my APIs correctly, or API or whatever it is. And because I foresee a time in the next month or two where I curse past me for just hacking together an API really quickly. And I think that's the price you're paying. Is you either spend a bit more time defining the API because you don't have the same type safety you would say in C++, where you just define a struct nicely. It's a bit hard, but you get benefits from it. You get the documentation.
So I think one of the things I would suggest there is it makes it easier to go back and revisit things later without hating yourself. When like we have a surprisingly large number of very small services there, and some of them are remarkably thin on some of the things that are going to make them great someday. But they work enough that we can move on. And going back and revisiting just that thing, when I bring more people onto the team that are more junior, will be easy for them to do. So we have a lot of services that are 100 lines of Python. And getting that going is less than a day usually. And yeah, it may not be perfect and et cetera, but that's the agile approach that we're taking is, do that and move on. Coming back, even a full rewrite, I'm not going to hate as much as I would have in the past.
Right, but also, isn't like splitting a microservice in the future, like isn't that not that painful?
I don't think I agree. As soon as you've got state, which you always do, there's going to be a database there, and now you're going to have to figure out what to do with that. So in my architecture that I showed you for my sock shop, the most painful thing in there would be to split one of those things that owns a database, because then I'd have to migrate the data.
I don't know that everything. I mean, not a single thing I put up there had a database in it. The only database was last.
Kyle hasn't done any work inside the sock shop, but there's a lot of things that
I've been avoiding
are best left sort of below the covers inside that.
So maybe design around your data model, do different services for that, but go no further
Yeah.
into any of it kind of thing.
I think that single responsibility principle is there.
Yeah.
If you get that right, if things scale by a single vector, so instead of scaling by I/O and CPU and this and that, if they're scaling by one thing, and if it owns one problem domain independently, in the future, if you make completely changes to that, it will change your overall architecture.
There is a judgment call here though, because you can go too far and go full factory at some point.
Yeah.
You don't necessarily want to.
Yeah, so that's the concern I have with the nano service. Like splitting something just because it can be split isn't the answer.
I mean, the way I came up with that architecture was fairly organic. I didn't sit down and plan it out. I started with the 80, and I was controlling it through like a Unix pipe or something. And I'm like, okay, I need something that's not me hacking away at it manually doing this. Okay, so I'll create a controller. Okay, the controller is going to listen to Kubernetes to get some how the CRD, and that's my database of stuff. And I'm like, okay, well, actually, I want some sort of dynamic lists here. Well, there's these blacklists that live online. Let's query those. So I queried those from within the service, and then I had this API already there. Basically, it's like you give this thing a URL and we'll query it periodically. So I just built to that API, built a service to it, rather than So I could have built that service directly in the other service. I could have just queried Elastic from within there. But I already had the ability to fetch out externally, so I didn't feel like there was much of a.
One of the controversial things that's out there today. So we're using Kubernetes, but I think it applies to other problem domains. Kubernetes has some really great extensible APIs and some database that backs them, and you can build something for it called a CRD, a custom resource definition. And you have this choice. I'm building something that I'm running in Kubernetes, and it's got to have a model to declare it, a model to apply it, a way to come into consistency, and a way to store that. Well, if I just use a CRD, a lot of the infrastructure is done for me. And all the RBAC and the authentication and so on stuff, it's perfect. And they're totally okay with that. But they've built their API and their system for a certain number of transactions per second. And if you are a different animal than that, you're going to hate yourself for it. So we were talking about this, that IP list we're talking about there, we want to do 1 million TPS on that, on the updates. And Kubernetes is talking about 100 TPS is a big number for them. And like you're not getting, so that was one of our challenges is what should be an extension of the system, of the platform we're on, versus what needs to be on our platform. Elastic is another example there. The platform that we're on, both Azure and Google, have effectively an Elastic that's just sitting around there that you're paying for. If we start logging a bunch of junk to that, I don't know if it necessarily, first of all, from a dollar standpoint, they didn't size it that way. It would be expensive for me. But secondly, I don't know if they were considering it being used for anything other than just sweeping up a bunch of log messages. So that's another one. So that's another driver for, you know, getting the architecture right and deciding what you need to own versus what could be something else that's there. It was a bit of a question mark.
Another fun little problem I had that I mentioned logging. So when the log generation itself logs can be fun. If for each log you generate a log, and that logs, and that logs.
Yeah. There are
I definitely ran into that.
the dirty laundry of the cloud lies in the logging, in my opinion. It is all there. It's so hard to get right.
I think one of the other interesting things is there's a bunch of, I don't know what you call them, platforms or something. So like Lightband has one, Vertex guys have one for building reactive applications. And they intentionally, so my impression is they intentionally go super extreme on the services, right? So one of the things Vertex will do is it will make a microservice for every single endpoint that we have. And it's all under the hood, so you don't worry about it when you're doing it, and they'll deploy it onto Kubernetes that way. And the argument is that it's easy to scale any particular endpoint. So I don't know if there's positives or negatives there. But
Is it possible they're licensed by endpoint?
Sorry?
Is it possible they're licensing by endpoint?
No, it's completely open source, right? So there's some connector things you can
But I mean, so are those endpoints communicating with each other?
So it depends. So they also have a bunch of magic bus stuff to communicate. You have endpoints which communicate to services, so it's kind of this whole reactive paradigm. So it's super service oriented.
Because at the endpoint, they happen to share the same root path, but they do very different things.
Who cares? Yeah, exactly.
That's
And they have
definitely
they have baked in, so you have data sources where you have whatever Java magic classes that store your data or get data, and they know, okay, I'll bundle those things together, or use the service directory.
I guess, yeah, one of the downsides of that would be if there's a lot of overhead to each individual service. I mean, looking at the sock shop thing, the amount of memory it consumes is ridiculous for what it's doing. And because of the Java, I mean, my little Python services are taking 20 megs. These things are taking like hundreds.
Yeah, actually, the other thing that's ridiculous there, like the tooling and the infrastructure around it, dwarfs the actual thing that's being tooled. Dwarfs it.
Well, I'm interested in how that scales because I mean, we're kind of
Once we start selling more socks, we'll see how
Yes.
that goes.
No, it's the scale down thing. Like it doesn't things don't necessarily scale down as well as they scale up in these architectures.
So one of the observations I had, your microservice is bad if there's an order to them. Like in the one I showed here, the front end can just in parallel do Ajax to all of the ones behind it, and they can answer out of order. But if it had talked to one and that had to synchronously talk to another to get the answer back, probably that wouldn't have been right to Brad's point about factoring it there. Like if you ask me and then I have to ask him and then I get the answer and then I send it to you, that's a pipeline. I may as well not have bothered.
And each step on the way is like taking the data out of memory.
It's like if the service on the back end that's answering to me is a pluggable.
Yeah, so it could be pluggable or it could be like connection pooling is another reason, I suppose.
Which is one of the comments of
That's true.
I get to, which is so the architecture, the solution architecture that we described here. To me, it feels like a lift and shift solution because there are tools out there that more or less solve the problem that we have. They're called API gateways. And to answer, to go back to you, the typical gateway architecture is you have your proxy, which is usually based on Nginx, but can be anything, and you have an entity provider, and your database. The proxy receives the connection, talks to the entity provider to determine whether this connection is allowed. The entity provider talks to the database to determine whether it has any records of this user or not. But this whole site thing here is pluggable. You can switch identity providers, you can write your own. Potentially, depending on which implementation is, like switch the API gateway implementation with use the same identity provider with them, assuming that they talk the same language. So which brings me to one of the other comments is that one of the things that I learned in my time with Kubernetes is try to first find an off-the-shelf solution.
Yes.
There might be one. And even if a month ago when you searched for it, you couldn't find anything, search again, because someone might have written
Even
something.
before
in
lunch,
the
you search
past.
for it.
No, I have 2 points. I actually meant to. I meant to bring that up in this talk, and I forgot. I definitely just. You might think that it's a really esoteric problem, but guaranteed someone's at least complained about it on the internet if they haven't already solved it. So take a look. And what you get might not be the exact fit for what you need, but maybe it's good enough. Or maybe you can enhance it. It's open source. Go. Or maybe you just need to adapt it a little bit.
So just to import it from latest, don't check the security, you're good.
With regards to this, full policy always.
Yes.
Although that's really dirty. You should
I feel like
actually
well,
use-
because it
And
seems
your
to
Docker
slow
files
stuff
and your
down.
pip install from git/master.
One point of my architecture, it's interesting you mentioned the ingress because it does look like an ingress gateway or an API gateway. What about east-west traffic? Would you consider that a candidate for an API gateway as well?
To some degrees, yes. So there are API gateways that are marketed as being super east-west. Off the top of my head, Con is the biggest one, which actually this past summer announced a deployment or contract for deploying it as a service mesh. So like the functionality is really interchangeable there. And even Istio, they have their own API gateway. Well, not Istio.
So we're using Ambassador.
Istio is based off of Envoy and Ambassador, which is the API gateway, is also based off Envoy, and
Yeah.
they share a lot of this infrastructure.
They share endpoint, it's great.
Yeah.
So if you were to implement this solution in a less lift and shift manner, would you suggest then that most of the integration would happen with the identity management, where you're saying this guy's allowed or not allowed, and we have something feeding into that, saying this I've seen problems with this one, therefore disallowed.
That's assuming that your problem is simple like this. In this case, it's based off the response from the backend. Now, if the backend itself has a type of log that says, okay, I respond with 200, but I log this as a warning, now you have a different problem. Maybe you might want to respond with not with a 200 or something else, or send a message off the message bus, or all the issues that you might run into with the API gateway. But you mentioned like NAND. Okay, so the API gateway looks out to the from IP, and it's the load balancer. It's not
And the API gateway also is an so now you got four.
If it's smart, you put the proxy like right in front of the load balancer to have an X44 header.
Yeah.
You use that, but
Oh.
And hope it's sanitized.
Anyone here tried using X-forwarded? That's a very tricky path to go down.
You just use
It's
the
what you
IETF
need.
forwarded for header. It's it's a
Not
standard.
everything is casing sensitive on it. Some of them don't accept the path, some of them do. Some of them they use the other, because forwarded for supersedes X-forwarded for, there's proxy on behalf of.
I know the App Engine puts something in along the way so you can figure out how long it took for
So,
everything it did.
so the two big ones that I'm aware of are Zipkin and Jaeger.
Yeah, I don't know.
So they add a header, it's timestamped all the way through, and then they have tooling that you can go and you can get like a Gantt chart of your requests through it. Yeah.
One challenge with the X forwarded for is it only works for HTTP. So if you're using any other protocols,
gRPC.
I mean, there's proxy protocol for TCP, but
Yeah.
One of the other things I find interesting with microservices is the scaling. So one of the classic problems I see is whenever you need to scale one thing, you have to scale the rest. And I think that's a fundamental architecture flaw that many people have. And it usually results from the how about now pattern.
for the load pattern.
The how about now. So instead of being reactive and getting information pushed to you, you're asking someone, tell me about this now, tell me about it now, tell me about it now. Now you have two people going,
Yeah.
tell me about it now.
So once you scale it, you need to scale things
You
in
have
time.
150 people say something, right? So this is one of the reasons why things like Kafka and the Lightbend stuff works extremely well, because you might scale your front end thing and you don't have to do anything on any of your back end stuff.
That's a big, in that architecture idea, one of my biggest disappointments in it right now is the fact that that IP was just querying every time
Yeah.
the controller queries. The controller is querying periodically.
Yeah.
Because there's no trigger. There's no event that can
The
trigger.
other thing you have is huge latency. How often do you pull it per second?
Yeah.
Maybe that's not fast enough for
Yeah,
5
exactly. It's
million.
okay. Now it needs to be every 100 milliseconds, every
Yeah, so
100
there,
microseconds.
there are other platforms out there for handling those kind of things that may or may not make sense for what you're building. But I think that's an interesting problem that I'm reading lots of blog posts, lots of people. We had an outage because this scaled and those scaled, but we couldn't possibly scale these enough because that thing was going to cause everything to fall over all the time.
Or you have one service per request. Things. You know, put one entire pipeline for requests.
Skilling also gets interesting the other way. Like most people think, well, scaling up is the problem, but the Kubernetes is going to also having to look at scaling up. Particularly when you do cluster scale. Say I start with a cluster of 2 nodes. Suddenly, I'm a shop on the Black Friday. I got 50 nodes now. After Black Friday, still got the 50 nodes, but they're all idle. So let's say, or maybe I got 10 nodes that each have one single pod on it. Okay, 4 nodes go away, but those 10 nodes could still be compressed up to 2 nodes. But because Kubernetes likes to spread itself, they all still have workloads. So Kubernetes will not delete those nodes until all of the workloads are gone. There are tools out there that will do it.
I think the other challenge with that is that you often end up scaling your data storage nodes. And then when you want to shrink them, suddenly
Yeah,
you're
that
moving
doesn't
a lot
work.
of data around to shrink.
Almost none of the data storage unshards.
Sorry?
None of the data storage unshards probably.
Yeah, exactly.
It's expanding
Big
maps.
challenge.
I just thought about that actually. So like, imagine, or speaking of like the scale down problem, you have 10 nodes each running one pod. Well, what if it's the only pod in the deployment? You don't want to just kill it to migrate it somewhere else because then you've lost service there. You need to spin up one somewhere else. It's kind of scaling up the scale down. It's a weird.
So
Coordinate, evict, reset.
Yeah.
well, yeah. So
But before evicting,
coordinate.
The solution is always restream everything back into Kafka and then back into your new set of storage.
Okay, so we've had some good conversation tonight. So I think we're going to keep moving this around. There's a few different people that have offered spots. So Simwave's offered theirs, MildVision's offered some spot. Do you guys want to do more like this, where there's good prepared discussion, and less like the bar one, or like you want to mix them up once in a while? We could talk about is once a month too frequent, not frequent enough? 7 o'clock, I'm not going to revisit because we voted on that. But anyway, if you got some comments for the next topics, put them online. I can go and get content for pretty much any topic. My sort of vision for this group is it's a generic leveling, like all of us are from different companies, but the skill sets we're talking about here are kind of spread across everybody's company. There's a lot of them that relate to big data, CI, CD, tooling, agile, this, that, the other thing. There are some other meetups in town that are vertically focused. You know, there's like agile and so on, but I think that there's benefit in having the same group of people discuss the common learnings they've had from similar companies, and that way, you know, one of us is going to do an investigation of some product and pick it and we'll explain why, and the others will just sort of trust that and use that as their finalist. So if you have any comments for the next topic, just let me know and I can go hunt down some people to speak on. Yeah,
Can I have a suggestion?
please.
It's relating to your talk. Your project is a refactoring of a monolith, or it's a green microservice?
It's greenfield. There's no
Oh, okay.
no refactor. Although yeah, it's pretty much greenfield.
Because this is issue, yeah. How you approach? Let's say it's a big project. How you approach the microservice approach? Martin Fowler says you first build the monolith because it's easy to figure out the whole thing, and then you refactor it to microservice. I don't know these examples where you approach a big project directly through the microservice.
So that's something I might be able to talk in the future. So the company that I'm building, we're focused on people who don't want to refactor the monolith, who want to keep it working the same way it does, but also want to have some of the flexibility of cloud. So we're trying to make some stuff to kind of hide those things like lack of subnets and so on from them. So eventually I'm going to hear some of their dirty laundry once I get a couple of drinks on them. So we'll see what they say. But
I mean, if anyone else has
we'll probably find some other people who've got some legacy they want to talk about.
We're in the process of migrating to monolith.
We've got an offer. Bart has offered to do the next talk. He will explain all of the dirty laundry, and all of the investors will be present.
Next month for sure.
All of the investors will be present for it. Okay. All right. Well, we can stay and chat or not. But thanks everybody for coming. We got a couple of new members. We had a few people that joined here tonight. So if you want to introduce yourselves to a couple of people, that way you can sort of join the crowd.